Hello everyone. First of all, while we kick off, I just want to apologise to those who thought they were coming to an SDK talk. I've used an SDK, but I can't talk about it. The guy who was doing the presentation, unfortunately, I believe is ill, so at the very last minute I've come to do this talk instead. So I'd just like to apologise if you are interested in SDK, this is not the talk for you. So that's the first apology. The second thing is I want to do this a bit more interactive than the other talks that have been going on. I don't generally do present at people. I generally get people to kind of, give their feedback as well. So I encourage questions during the whole presentation. And if you want to if you know more about particular bits than I do, feel free to kind of put your bit in. The reason why I do this, two reasons. One, because I don't claim to be the world's expert on Storm or Spark. In fact, I don't know a massive amount about them. My company, Claritize, we started looking at which platform to use for ourselves, and so we did a big evaluation on the two, which means that while we built prototypes with them, I've not built massive real-world applications, and I do think, as many of you software developers know, when you actually go and build something big with a piece of software, you actually get to find out about the reality of it. And there's been, throughout the history of computer science, so many cases where this new shiny tool comes along and everyone goes, wow, that's amazing, and in prototypes it does amazing jobs, but then actually when you start scaling it up or use it in real world scenarios, you find it's incredibly hard to use. So if any of you are Storm or Spark programmers and you've used it heavily in your applications, you probably do know more than me. But this will give you a high level view and a comparison between the two. So just as a show of hands, who's used Storm? Okay, that's a good one. Who's used Spark? Okay. And there was about three, who's used both? There's about 3 or 4 people there. Cool. Alright, so it'll be interesting what you guys think of this presentation. And do pipe in if you have an opinion that I have not expressed, do kind of. So again, yeah, quick apology. And yeah, I hope this presentation is interesting and useful for you guys. And if there's a bit that you're not sure about or you want to know more, do cut in during the presentation. Okay, so outline of the presentation. So I'm going to talk about what is stream processing to start with. And then I'm going to talk about what is Storm and what is Spark and how do they differ. I think there's been a lot of talking about using Spark recently, and I think there's a lot of momentum going behind it. From my own point of view, when I looked at doing stream processing for Claritize, we did evaluate Storm when Twitter built Storm. Just out of interest, did anyone use Storm when it was a Twitter product as opposed to when it was an Apache product? Okay, so you were quite an early adopter of Storm. It's quite interesting now that a lot of technologies are building around Storm to kind of make it almost Spark-like. But it does seem that Storm has been used in quite a few big production scenarios, which is great. Whereas Spark is still quite, my kind of feeling is it's still quite new. But I'll go through that anyway. Right. I'm sure these slides will get shared with everyone, so if you want to look at the bits of information I used to gather my information when we did the evaluations, you can use them from this slide here. Right, again, yeah, just if you've used it, you probably know a bit more than me. Okay, so what is stream processing? So I suspect probably quite a few know already, but basically stream processing is different than batch in that it generally operates on a row level. When information comes in, it gets processed. And this is a very different paradigm than batch processing. So batch processing, almost the MapReduce way of doing things. And then there's loads of examples of different versions of batch processing where you've got the data and you go off and you process it in batches. So you kick off a processing, it gets processed and comes back to you. Whereas stream processing is more the event coming in and you processing it. So Storm is really a classic stream processing system. The event comes in, you process it, it goes out. Whereas Spark is more of a, considered a micro-batch processing system. So it's much closer in design to a classic Hadoop, really, but it's been designed to do it way faster. And in fact, a lot of operations in memory to speed things up. So
stream processing can be particularly useful when timing is a critical issue. So basically latency. So has anyone worked on so like a price feed for a financial services company? Or you know when you go on, has anyone worked on an ad exchange? Okay. So basically there's a few classic applications where latency is absolutely key. When you go on to a website, the adverts that appear at the side have been bidded for via some form of ad exchange. Those bids and people satisfying and choosing which advert to choose happens super quickly. And that's a classic example where latency is king. Where what you don't want to happen is a web page come up and then 5 seconds later the advert comes up and you've already gone to the next web page. So I think for classic cases where latency is king, you're probably looking for more of a stream processing, where you're in a scenario where you want to process things and latency isn't the key, but maybe getting it processed within 10 minutes, but you need more accuracy, then, or you know, even if it's a few seconds later, maybe 10 seconds, batch processing or micro batching could be more for you. And then a lot of people are talking about complex event processing, where you don't just do one thing from an event, and a bidding system is an example of complex event processing. But there you go. Okay, so basically latency is important, stream processing. Batch processing is doing a job with a set of data. MapReduce is a classic example. And a lot of people are talking about micro batches, which is kind of a halfway house between batching and streaming. And we'll talk about this a bit later as well, because what's happened is since Spark's come along, well actually I don't think it's since Spark, but Storm has started looking at introducing technologies that do micro batching in Storm to give it more of the capabilities, or similar capabilities to Spark. You guys were all very quiet. So I've done this presentation once before, and I didn't even get to this slide without about 20 questions. So do feel free to fire any questions. I don't want to pick on anyone in the audience, so you know, if you ask questions, then it'll make it easier for us. Okay, so what is Storm? Okay, everyone knows it's an Apache project. It's free and open source. I think weirdly, Storm, even though it's used in quite a few production environments, I think the version that they claim it's for, I think they still kind of almost badge it as like a beta product, whereas actually it's quite a mature product and in quite a few production environments. And at the back of the slides, I'm going to list, I might be getting gassed or something, I'm going to list some of the scenarios that Storm's used in real production environments. Whereas Spark, which is a much newer project, and isn't used in as many production environments from what I can see. And certainly if you search on the web and you look for cases where Spark is being used, there's less people claiming they're using it in production environments. People are tending to play with it a bit more to see what it can do. It seems to be more mature in terms of the version they claim it's at. So, but really from my point of view, it kind of feels like Storm is a little bit more mature and is used in a few more production environments. Again, it's essentially a stream processing system. And yeah, the aim of this presentation really is, if you're kind of going, well, which one should I use for my projects, this is to kind of give you a bit of a feel. Right, okay, so Storm has the concept of spouts and bolts and topologies. The idea is that you have spouts which basically the input data into Storm. And unlike MapReduce, so if you're using a batch processing like Hadoop MapReduce as a classic example, when you want to do something, when someone clicks on the UI, it goes off and kicks something to do some processing. Whereas Storm is different in that the data coming in is what causes the processing. Okay, so the data coming in could be, if you're using Apache, and I can never pronounce this without sounding really stupid here, Kafka. I always say Kafka, but Kafka, Apache Kafka.
New project.
is a classic case where it could be logs coming in, and the second a log comes in, it can go straight into Storm, and Storm can kick off processing. Now, that might be something you want to do if you're looking at web logs, and you want to take action if a click from a certain country comes in. Maybe you want to set off a series of alarms or whatever. It's a classic case of the data kicks off the processing, whereas MapReduce would be used in a classic example where if you want to maybe fill up a new dashboard based on the user clicking on something like a user interaction. So the idea with Storm is you have a topology, and the data is set up in something called a tuple, and I'll talk about a tuple in a minute. But what you do is the data goes into the Storm topology, and then depending on the data will be routed around the Storm topology. So the Storm topology has a concept of filters, and depending on exactly what the data is, you can set it up so that it will go around different parts of your topology. So you're optimizing your processing based on how you set up your topology. So I think the best way to think of the Storm is the topology is really the key of how you decide how things are processed. Events come in, and that's how it's kicked off, and tuples are how the data's held. I think, everyone seems to give Twitter as the example for Storm. I think basically because Twitter produced Storm to start with. But processing tweets is a classic example. And this is just showing you that the bolts kicking out different data than they're putting in. So I think this example shows a tweet going in, a JSON string going to a textual filter, the full JSON string sending to a bolt that does storage, and then there's an example of one bolt combining the output from two different bolts. So it's a classic case of you might be doing a join between two different bolts. Maybe you're correlating, I think in this case it's news output with Twitter tweets. So maybe you're trying to find correlations between tweets and news outputs. Am I lost anyone? Because everyone's so quiet. Everyone understands, yeah? Is everyone well ahead of me? You're kind of all compiling it in your head and deploying it. Right. So, as we said, data is sent as events, which is push, from the spouts into the bolts. And as we said, unlike the MapReduce pattern, Storm processes stuff as long as the topology is there. I.e., once the topology is up and events come in, it will just process. There isn't a start and end as such. It really is, the start and end is really created by setting up the topology and bringing it down. And so, well, go back inside. There we go, sorry. Okay, so, what's weird, it shows a different thing on the screen here than you guys, so, okay. We'll talk about a tuple. This is weird. Okay, I'll look on here. So a tuple is basically a name list of values. And by default, all the basic types are supported. You can add any type by providing serializers for your type. As basically Storm holds all the values in string. So what you do is you know what you're holding in the field, and you basically use some get methods to get the data back out, and it deserializes it. Now the thing is, it's a name set of values, but you don't have to declare the types in advance, because really it's like a name. Yeah, it's just a name value string, but you know kind of what's in the data, and serializers are used to get the data in and out. Bolts, in theory, can be in any language. You do need a client lib. Non-JVM languages communicate to Storm via a JSON-based protocol. And there's out-of-the-box client libs for all the JVM languages, such as Java, Scala, Ruby, Python, and there's also ones for Ruby, Python, JavaScript, and Perl.
So all of the languages have the same sort of precedence and status in terms of clients?
That's a good question. I don't know the answer to that. Does anyone else know the answer to that?
There's a bias to Java.
Yeah, Java and Clojure tend to be the two that are best supported.
They're Twitter's language of choice with a bit of Scala thrown in.
Is Storm actually written in Clojure?
Parts of it are.
Okay. Parts of it are Java, aren't they?
Yeah.
Has anyone used Clojure much? What about Scala? Everyone seems to be using Scala now.
You've got Scala
there. So I've only tried Storm, and basically we've clarified, we've only done prototyping with Storm using Java. Has anyone used it in Scala or any of the other languages?
Used it with closure.
How did you find it?
It's pretty good. It's pretty good abstraction.
Was that riding bolts in Clojure, or there's a Clojure API for defining topologies, which looked really easy to use?
Both actually.
Yeah.
Yeah. It is very good to use to define topology. It's a while since I did that.
Okay.
And the thing that kind of messes with my head a little bit is this concept that Storm really provides what they call at least once processing, which is that Storm kind of guarantees that everything will be processed at least once. And if you want to do something so you get only once processing, you actually either have to do the calculations yourself to make sure you're not over-processing, or you need to use a technology like Trident. Has anyone used Trident here? How have you found it?
It was just an issue we were looking at solving a couple of years ago. It's complicated actually. I think we were thinking more about addressing how we manage the data to just avoid having to use it.
Okay, so you got to the point where you went, actually this is a way, because I looked at Trident, it does look really quite complex.
Well, that's the point. It's there to solve all this. It's actually like a consistency management solution. You pay the same price as you would anywhere else.
Yeah, it's tough.
The problem with exactly once is that once your machine fails, the rest of your system doesn't know what exactly happened to it. And the Storm can recover from a node failure, but it reruns stuff. That's why they make the guarantee.
Yeah, but that can be problematic if you're doing exact calculations.
Yeah, that's right. And if you read a lot of what Nathan Mars writes about Storm, he advocates it as part of the Lambda architecture, and he says your real-time information through Storm, you allow some small discrepancies in the event of node failures, because you have some other batch process that comes along and cleans it up afterwards and does it right.
And I think the theory actually is Twitter don't care about perfection. They basically want current news, and it's more important than correctness. So that basically they can cheat on this.
Yeah. So how
if you're doing other things, you may not want that same.
And that makes sense. I think for latency type systems, that's often the case, isn't it? I mean, if you're looking at finance and you're looking at market data, often it's key what the last price is. You don't actually care. If you start missing a few prices, you probably don't care.
Yeah, that's right. And if you're looking for trending topics, if you're a few out on the count behind some of the trending topics,
You don't.
yeah, it doesn't matter.
And people don't notice inconsistency that much.
Yeah.
So from my point of view, when we looked at it, so Claritize, we do data mining. So I guess the statistical calculations are key for us. So for us, at least once processing didn't really cut it, because it meant that we could actually if we had an issue and one node went over and it went to another one and we started over-calculating, it would be an issue for us. Which is why, one of the reasons why we started then looking at Storm Trident, and then I kind of did the same thing as you, went, this looks really complicated. So I kind of backed off that. So I've never actually tried it. Right, what's Spark? Spark is a fast, general-purpose engine for large-scale data processing. And I got that straight off the Apache, kind of what they say about it. Essentially, it's a super fast batch processing engine. It can do micro-batching, which almost simulates streams. And in fact, there is something called Spark streaming, which I'll talk about in a minute, which uses a concept which is D-streams, but we'll get onto that in a second. The idea for Spark, so I think a couple of guys started talking about the Lambda architecture, which is, I think the idea behind the Lambda architecture is to prevent the scenario where people were starting to build batch processing logic and real-time logic, and they were having to build it twice. And I think the Lambda architecture is really an idea that you have one piece of logic and you can use it in either way. I think it's the general concept of that. And so Spark is kind of very similar. The idea is that it can almost be pseudo real-time, so latency is not so bad as a really slow batch processing system. But it also does things in micro batches, so it can act like a batch processing system. So the idea is to have the same code, I've got some code, but it's the same code for streaming as well as batch processing. But it's absolutely not the same as Storm. And here's a nice pretty diagram, because diagrams are always good. I think this is really just to show you guys what you get with Spark pretty much out of the box. Did anyone have a question? It sounds like there was so Spark SQL, Spark Streaming, machine learning library, which is just built right in, and GraphX. Has anyone used the machine learning part of Spark? How did you find it?
It's been really good. We've used the predictive recommendation algorithms, and yeah, they've been excellent.
Oh, right.
Yeah.
That's nothing to do with the mount stuff.
No, it's not. I think you can use mounts with it, but I think the mlib library is different.
Yeah, I mean they've ported, I think, effectively the same algorithms into Spark, and you get a lot of the same functionality, but big difference is it does it in memory where it can, and it runs much faster.
So the one thing I've not got to the point of, some people talk about what Spark does if your algorithms use too much memory, and whether Spark slows right down. Have you got any opinion on that? Because that's one thing I've not got to yet.
If you end up spilling out to disk, it really does slow things down a lot. If you can avoid doing that and get enough resources on your nodes that you can do it in memory, it is really hungry for resources to get the stuff to run.
Okay, so that's one thing to bear in mind.
There's another one, which is if you're running on Yarn and you start asking for consuming a lot more memory than you're requested, you will get killed for the sake of everything.
On Yarn,
Right.
okay. Interesting to me.
But you can turn that feature off in Yarn.
Okay,
Like
but by default it's on.
Don't know.
Okay, so the idea of Spark was to combine batch processing and stream processing. Well, it was to combine online and batch, I suppose. Real-time batch. Comes out of the box with algorithms for machine learning. It's like Apache out. The other thing is it has an interactive shell like Python, so you can try stuff out immediately. And it is a lovely shell, actually. It is great to use. And the core concept of Spark is a data set is what's called they call it a resilient distributed data set. But basically what it is, it's a read-only partition collection of records. So the best way to think of it is kind of like a read-only table, right? And what you do is you process it and you move it along. And the idea is that you, once you process it, you can put kind of the IDD into a function, then you can put it into another function, etc., etc. And you build up your processing that way. Here's like a Spark example I nicked from the Apache Spark thing. And I think it's just showing you processing some Wikipedia stuff, doing similar to the other example where it's working out page ranking and building up kind of graphs between stuff. It's kind of standard stuff. Spark streaming. So I guess this is the bit that's probably more comparable to Storm, even though it is actually still very different. And the concept of this is they've got a basic data type called a D stream. Which is the abstraction provided by Spark Streaming, which is really a kind of the best way to think of it is a sequence of RDDs. So that table I talked about earlier, and it can be thought of almost like a continuous sequence of RDDs. Now, I believe with Spark Streaming, although I haven't tried this yet, you can actually combine RDDs and streams together, and it just kind of deals with it automatically. Has anyone used Spark Streaming?
I've worked with a Hadoop distributor. We have people using it in the field. It has a reputation for not being that stable after a couple of days to do that memory consumption. You know, so the question is, would you use it in production yet? And that's a bold decision to make. Storm has been out there for a lot longer, and Spark's notion of 1.0 release is kind of optimistic.
It is interesting. So we're working with a company that are processing data from a telecoms company producing. Does anyone know telecoms? So basically, they're processing call data records. Every time you make a phone call, it generates a call data record, and that's a record that shows that you're calling someone else. Now, as it turns out, when you make a call, typically, if you're calling someone in a local area, you only have one of those records, right? So it goes to one exchange, records that you phone them, and records you as the caller and them as the destination. But actually, typically, if you call someone far away, like if you're on mobile in a different part of the country, you create a call data, a partial call data record for every leg of the call, right? So each phone call can generate, I don't know, 8, 9, depending on where you are. And what they do is they get all their call data records that they generate every day, and this customer generates 800 million of these records a day. And they're using Spark streaming to process it. And I think their findings were it was a little bit unstable. It's great when it stays up, but yeah, it's a little bit unstable as their thing. So my kind of feel is it's not quite production ready, although I think some people are playing with it, and we're Clarity is going to play with it a lot more.
Because a lot of the place for Spark is kind of as a natural replacement. How do you make them more accessible with the MapReduce framework, isn't it?
Yeah, it is. The reason why, in that example, they're using it for processing, because you could argue that call data records coming in is more of a event processing architecture. Well, I guess they don't need the answer immediately, so latency isn't the issue for them. So actually, they get a higher throughput by waiting and micro-batching it.
Yeah. I don't know. But is that saying if they're using batches, they don't need streaming, do they? Well, I suppose what's the way if they're running it?
Well, I think they're running it continuously. Right. So I guess they don't want to then start doing a job and then just trying to work out the results. They want to process as it comes in. So I guess they could possibly use Storm and use one of the technologies that kind of gives them micro-batching and Storm a bit. But I guess they wanted to go into the Spark thing.
And do you generally get that Lambda architecture benefit of like, well, you haven't been running your continuous process for a while, let's run it over as a big job to catch up and then run it continuously afterwards? Is that
why they did it? Or
is that possible? Is that because I think one of the things with the streaming, one of the things we found on the reasons we struggled with Storm to a certain extent is you've got to initially establish your data and your base thing, and that you spend a lot of time replaying and actually making it work in both sides of the advantages. Just having a hybrid system in the Lambda architecture generally is you kind of don't have any extra cost whether you're running a big batch job to regenerate a new data set. So,
but you have to have 2 bits of code, don't you?
well, actually, so I think you can do it without writing 2 bits of code if you write the right bits of code at the micro batch level, right? Surely, so if that's the benefit. Is that not the benefit of
that's the idea of I guess the reality. So we're moving Claritize over to Spark now. 3 months' time, ask me the question and I'll give you my answer. But yeah, that's why we're doing it. Because so what we do, I don't know how much you guys know about data mining, but we're data mining 2 things. So we come along to a company, they've got loads of data, right? So we've got 2 problems. One is we want to process their data from now on, which is kind of streaming, but we actually also want to process what they've had before, so the historical stuff. So you kind of got 2 choices. What do? You pull the data out and then you push it through a streaming system like Storm, which is, I guess, you're almost trying to do replaying, really, and act like it's streaming live. Well, then you've got an issue that, well, if you're doing a streaming system and you're timestamping as it comes in, if you try and do replay, you're going to mess up all your timestamps. So I guess from our point of view, one reason why we like it is because it, in theory, gives us that, but whether it does or not. All right, functions, features. How am I doing time-wise?
We've got 20 minutes.
Cool. All right, I've only got a few slides left, so we're almost finished, guys. So here's just and the problem is with this, the comparing functions, features. It is like comparing apples with oranges and pears and stuff, because there are loads of different features in both. And if I try to put a slide up with all the features, it would be so long it's almost ridiculous. But I think the general features that I looked at, whether it was important, was obviously Storm doesn't do micro-batching, Spark does. It does with Triton, but not kind of out of the box. Storm doesn't have an interactive shell at the moment. I don't know whether there's any work to give it one, but Spark does, and the interactive shell actually is quite useful. There's no real concept of topologies in Spark, but I guess the topology management is quite a nice feature. I guess when you're kind of load sharing out, you're kind of in control of it, whereas Spark, I guess it's less explicit. And the integration with other stuff, with other stuff, Kafka, I think is fairly similar. But you do get more out-of-the-box libraries with with Spark, like machine learning, GraphX, etc. And the latency is for Storm is sub-second, and it's kind of a few seconds or close to that with Spark. Here's just a list of the languages it's easily compatible with. As we talked about, Storm, Clojure, Java, Scala, and Spark streaming, Java, Scala, Python. The reliability models are different, as we talked about, and the things it runs on, they're pretty similar now, I think, between Storm and Spark. Right, speed. This is the thing, comparing speed. Now, I looked at loads and loads of links on this, and there's loads of debates on which one's faster, and it really seems to come down to what are you using it for. The only people that have done an absolute direct comparison that I could find is Duke University Computer Science Test. They managed to do a piece of processing where they managed to do 10,000 records a second per node using Storm, and using the same processing they did 400,000 records a second per node with Spark. Now, my guesses are that when they did this, they managed to use Spark so that the processing was simple enough that they managed to ran all in memory, so they didn't have any thrashing to disk. That is a pretty faster record in Spark, but I guess it really depends on what you're processing. So, you know, if you can follow the link and see what they did. I think I've put it down there. Yep, it's down there. And then they'll talk about what sort of processing they did. Market adoption. The number of contributors, I kind of did a quick look. There seems to be a few over 100 with Storm. There's about 300 now with Spark. I do think there seems to be a lot of momentum going behind Spark, even though most of us who've tried it kind of feel like it doesn't feel as production ready as Storm does, and Storm seems to be used in more production environments. Storm's latest version, when I did these slides, it was a few months ago now, they claim is 0.10 beta, whereas Spark says 1.41, which seems a bit optimistic to me, but I guess that there is a lot of momentum behind Spark. And yeah, that's kind of further reading. So that's pretty much it, presentation-wise. I actually designed this presentation only to be about 20 minutes long, which is why I managed to get through it so quickly, and why I tried to encourage so many questions. So is there any actual questions at the end?
Trident, I don't know. I was hoping you could tell me about that.
Oh, what's Trident? So the idea of Trident is that it's a technology that can sit on above Storm that can give you exact once processing. And so the idea is it prevents replaying too much. The problem is it seems quite complex, whereas it's built into Spark, so it won't do that. Storm, if that's an issue for you, which for me, if you're calculating a number, right, and you need to add everything up that you're getting in, if you use Storm, you can get in scenarios where you will overcount.
But that's really about, in Storm terms, that's dependencies between bolts almost, in the sense that your bolt further down is dependent on some of what's in the groups.
So for forces, correct me if this is wrong, but forces keep track of messages that are in delivery and they're waiting for acknowledgement, and if it eventually replays them, if those go down, or there's a recovery process. So all Trident's doing is stopping you from replaying. It's like a sports only JMS constraint or something like that, I think.
Yeah, I'm not sure quite how it does it. But so you use Storm, don't you?
Yeah.
Yeah, and so do you ever have that problem?
We never had that problem, no, because we're extracting data.
So I guess you don't care, do you?
Have you deliberately tried to kill Storm thing processes and see how it reacts?
Not as far as I know, no. But for us, it's just, extract an entity, calculate sentiment, so you can run that as many times as you want.
It's really doing the CEP stuff, so you're actually generating like trigger events that go off and do stuff, I suppose, becomes more relevant what you actually want to. Because we looked at Storm for real-time fraud detection. We had some stuff that was actually just data aggregation. That's when we folded back into Senate here. recoverable, the data set's reliable, but there were some cases where we were trying to send up a message or something.
Like an alarm or something.
And actually, in the end, we just said, well, we'll just make that tolerant to recovery that work.
Do you test that failure handling then?
Probably not as well as we should have done. Again, it's not, again, like many of these systems, perfect accuracy is not as, it's not super critical, but actually there's a running gag in the payments industry that people like to see a bit of fraud detection going on, whether or not it's accurate or not.
But it's got to be in the exact science anyway, isn't it, fraud detection?
No, absolutely, yeah. But the trouble is you can get these really, especially if you're using like data set and approximate data types and things like that, you have to be really, really aware of the edges, because it's, people also can get really, really annoyed on their transactions. So they can't do stuff.
Yeah, no, I get that. With Lloyds Bank, because I heard some of the bank providers now, they actually they get data feeds from the CDRs. So when you make a phone call abroad, your bank gets notified that you're actually abroad. And I think that was an attempt to reduce the false positive. When you go to France and you've not been for ages, and suddenly they mark your card as fraudulent. I remember phoning up Lloyds, saying to them I was going to Prague, went to a hotel in Prague, got there, tried to pay, card got blocked, ended up having to phone Lloyds back home. I was really wound up. But I guess if someone had stolen my card, I wouldn't have been so annoyed. But now apparently, the banks are getting feeds from the CDRs, from the telco provider. So now when I travel abroad, as long as my mobile's with me, my bank have already notified their fraud detection system. Typically will get an alert so that they don't then block the
So
card.
we just steal your phone and your card?
Yeah. Yeah, I was thinking about it.
Oh yeah, they didn't think of that, did they?
Somebody has.
Any other questions?
I think, maybe I'm wrong, I think the motivation for the talk was that you were trying to decide yourself. Is that right?
Yeah, so we were choosing.
Where have you got to?
We're going to use. So we've done two things. So we do data mining, right? And accuracy, to some degree, is actually important. Originally, when I built it, we built our own platform. We looked at Storm at the time, and I basically went, Twitter have built this. If they don't care about it anymore, I could be screwed if I use this as a platform. Turns out Storm has become quite stable, and Apache took it on, and the rest is history. So half of me was quite gutted that I didn't go down the Storm route then. Now we've got our own platform. We're kind of going, well, how do we mature the platform? And actually, do we want to keep maturing the platform, or actually, do we really care just about the algorithms? And so we've kind of got to the point where we go, we just care about the algorithms. So in which case, which platform do we move to? And we're heading towards Spark. So it means that, worst comes to the worst, if we find Spark isn't reliable in production, we can use our own platform. But actually, longer term, I kind of want to use a platform that's generally supported by the community. So we're actually going down the Spark route. And actually, latency isn't the issue for us anyway.
Sounds like the right choice to me, because if you want accuracy of data, I think Storm has just got areas where it's going to make mistakes, and you need that ability to be able to go back to your raw data and be able to calculate accurate results.
Yeah, and I think that's why we're going to go down. It's tough, isn't it? I mean, the problem is with these, using something like a platform like Storm or Spark, it has a big effect on your architecture going forward, doesn't it? Once you get on board of a piece of technology like this, it pushes you in a particular direction, whichever direction it matures in. But
that's for sure. Things like, if you haven't already got Apache infrastructure, if you're not used to running a zookeeper, that was one of the big problems we had with Spark, is actually from operations transitions. It's quite a big change if you've not worked with that stuff before, especially if you're not familiar with all the ways it goes wrong. I think probably everyone would.
Yeah, my particular Spark, I'm one of those people who contribute to it, shared lane, is I only trust its long-term stability for running process due to its tendency to run out of memory and stuff like that. So you have a plan to say, we're going to reboot this every couple of days in your workflow, that avoids that problem. The other one is the code API level. It's very rapidly evolving, and they do care about consistency, but maybe not enough. And some of the leading edge features like the data frames API are really good, but it's just stability is still something to be questioned. Storm, people like Yahoo use a big scale, and they will complain pretty aggressively. Storm
so, is anyone using Apache? Say this wrong, Kafka.
Yeah, we use Kafka.
The APIs for that are changing too rapidly. It's a classic case, and I think it's similar to Spark. I find it really annoying because the latest version have now got like new APIs for the consumers, for the producers, and apparently new APIs coming on for the consumers as well. But it's just it's annoying when you try and rely on these things and the API changes so quickly.
Everyone fears new versions.
But then, I mean, what do? You build them yourselves, and then you build it yourself, and how much effort and energy does that
on the
take?
maintenance debt, you thought you take on that same debt on as well. You hold off, you put off that kind of crisis until later, but maybe that's better.
You fork when you need it, and you hope it gets back into the truck.
Yeah, that's the problem. You hope you get back.
Yeah.
And like LinkedIn, they have their own branch of Hadoop they maintain. And it's like on Facebook trying to get IPv6 support into this bits of code, and it's kind of they're really divergent. They're trying to get back in, but basically they're full-time people trying to basically get Apache in there. Those are security. Which ones do you think work in a secure environment?
To be honest, I haven't actually assessed that. Did you have a viewpoint?
None, except that in a Yarn cluster, your Kerberos tokens expire after about 72 hours. There is a fix for SPA 1.5 that handles this, like give the key tab and keep running. Otherwise, that reboots every 2 days strategy. Don't dismiss it. Google kill their containers and restart them all the time because it's easy to worry about memory management in C++ code. You just restart these things.
And actually, it's not a bad. So, I mean, my background is telecoms and banking, and I know. So I used to work at Goldman Sachs, and you know what? They did that with their processes. It's just easier, isn't it? If you just go, well, actually, we don't rely on the process being able to stay up for ages. We'll just literally kill it and have another one running that can take the load share while that goes down.
And it certainly tests your recovery algorithms quite nicely because you're doing it all the time. It's not unusual.
That's true.
So I think I have a question, but more a tip. I recently did some stuff with Storm, and if you want to spin up a Storm cluster on EC2 and follow the documentation website that recommends Storm deploy, which is Nathan Mara's project. This doesn't look like it's been maintained for ages. It doesn't work with the latest version. I lost 2 days to repair it. There's another project called Storm Deploy Alternative that someone spun up, and that looks much more actively maintained. So just go straight to that. It just works and it's great. That's just a tip if you're going to try it on EC2.
Cool. Thank you. Probably have saved some of those 2 days. Cool. Well, thank you very much for coming. I'm sorry again it wasn't the SDK. All I can say is I've used an SDK before and they're really good. Thanks everyone.